Let's do a bit of an exercise. I have a piece of code here. And as you can see, I have variable a that is a function. And inside of that function, we have another variable, const b, that is also a function that we run at the end, the b function. And then inside of that, we also have a c function. But this time around, c is an object that has property high, which is a function. And at the end, we're calling c.high. Just to clear this up, I'm going to add a here in the console log. I'm going to add b in the console log. And then finally, c in the console log. Now, when I run this function, it's going to execute this piece of code, which goes through all the steps and executes b, which will execute this piece of code. And this b will finish off with executing c.high. Hit pause and think about what's going to happen, because in just a few seconds, we're going to find out. Let's see. Is that what you expected? Let's see what happened here. A equals to the window object, or the this keyword here refers to window. And that makes sense, right? We called A. Who called A? Well, the window object called A, right? What about B though? Who called B? It's nested inside the A function. Maybe you thought that we would have something else as B. But that's not really the case, right? Remember, all we did was we called the A function, and the A function executed this piece of code. And the B function, well, who called the B function? There's nothing to the left of the B, right? There's no other object that called B. So in this case, what's to the left of the dot? Well, nothing has changed, and the this keyword, who called me, is still window, because we have window.a function that got called, and inside of here, we called the b function. But to the left of the dot, it's still the window object. Now, when we get to C, that's when the interesting thing happens, because we have an object, and that should trigger something for us. As soon as we have an object, we now see that c.high got called. So when we call high, what's the this keyword? Well, high was called right here. And who called high? Well, C did. So the this keyword, or who called me, is the high or the C object. And this is unlike anything we've seen before. Remember when I told you about lexical scope, lexical environment? How the compiler knew right away, without running any piece of code, what variables functions had access to? It almost looks like lexical scope doesn't work with this. It doesn't really matter where we write it in the piece of code, right? All that matters is how it gets called. During invocation, who calls it? It matters how the function was called. Let me show you another interesting example. Let's say we have an object, and this object will have name once again, and Billy's going to make an appearance once again. And Billy is going to sing. And here we'll just do console log this. Nothing new here. We've seen this before. But let's add something new to this. And one of the biggest gotchas when it comes to this keyword. If in here I create another variable, and this variable will be another function, that will be function, and in here we'll have console.log this. And just for clarity, let's just say B for this one and A for this one. And the sing function will actually at the very end call the another function. What do you think will happen here? Now, again, the REPL over here has some safeguards in place, so it actually won't let us run this properly. So I'm going to copy this and open up the console. Let's refresh, copy and paste here. Now, when I create this object and I now run object.sing, let's see what happens. Is that what you expected? I have A, so the value of this referring to the object that had Billy and the sing function. That makes a lot of sense. But what about this one? What just happened here? This doesn't make sense at all, right? I mean, isn't this inside of the object over here? Why is this referring to the window object? And this is, like I said, one of the biggest gotchas when it comes to the this keyword. Because the this keyword is not lexically scoped, that is, it doesn't matter where it is written. It matters how the function was called. What actually happened underneath the hood is that object.sing ran, and this object.sing inside of the sing function, that's where another function got ran. Object didn't really call another function. The sing function did. In JavaScript, this keyword defaults to the window object in here. I know, it's extremely confusing, right? And this created a lot of problems for people because this error was so common. Remember this? In JavaScript, our lexical scope, that is available data variables where the function was defined, determines our available variables, not where the function is called, which is called dynamic scoping. But there's actually a little footnote to this statement, right? Because everything in JavaScript is actually lexically scoped. How we write it determines what we have available, except for the this keyword. The this keyword is actually dynamically scoped. That is, it doesn't matter where it's written, it matters how the function was called. So how do we fix this problem? How can we avoid this pitfall that a lot of people had in the past? Well, there's two ways to do this. Let's have a look. If I copy this back, and let's just refresh here, I can solve this issue using what we got in ES6, arrow functions. And you may have heard the term arrow functions are lexically bound. That is, arrow functions has a lexical this behavior, unlike normal functions. So if I change this function to an arrow function instead, it's going to lexically bind this. That is, hey, what object is surrounding this while the main object is? So by just doing this, if I run this, say sing, hey, look at that, problem solved. Not too bad, right? And that's what arrow functions gave us, which was amazing. It prevents a lot of this confusion. And this is something we're going to talk more about in the object-oriented programming section. But what did we do before we had ES6 and arrow functions? Another way that we were able to do this before we had arrow functions was to do something like this, where I return another function and I bind to this, which, because we're doing this line of code outside of this function, this is going to refer to the object. Let's see what happens when I do that. Oh, and I have to refresh. Let's try that again. And if I do object.sing, but then object.sing actually returns another function. So if I do object.sing, call the function, and then call the function again, which will be running this line of code, I get, look at that. Both this keywords are now part of the object. Now, I know that's really confusing. I just wanted to show you what we did to solve this issue before we had arrow functions. But what does bind really do? Well, in the next video, we're going to find out. I just remembered that there is one more way of solving this issue. The issue of this keyword in here inside of another function being the window object. And this is something that you may have seen a lot, especially if you've worked in the past with jQuery or the first version of Angular, where in order for us to capture the this value, and in order to have it referencing the object, what we would do is outside of the function itself, create a reference so that, for example, variable self is equal to this. And because at the time this line is run, this is still inside of the object, we're going to maintain that reference to the object so that here we can use self inside of the another function. So that if I run this function, I see that both the sing function has a reference to this, which is the object, and also the another function has the reference to the object using the self variable.